this time, the goal is kind of opposite of some of the other problems that we've done. This time, I have a graph, and I want to write the polynomial function instead of the other way around. Let's look first at end behavior. And by look at end behavior, I do mean look. We can just look at the graph and see what it's doing. As I go to the left, as my x values go to the left, my graph is going up. So I'm going to say up left. As my x values go to the right, my y values, my graph, is also going up. So I'm going up on both ends. Well, up both left and right says that my degree is going to be even, similar to y equals x squared. And the leading coefficient is positive. If it were negative, I'd be going down both ends. It's positive, so I'm going up. You'll see my own private abbreviation for leading coefficient. Next, let's look at intercepts. What we need are x-intercepts so that we can make factors out of them. Here's my first x-intercept, or my leftmost x-intercept at -1, 0. At -1, 0, I need to know what the multiplicity is there, and for that I'm going to look at what the graph is doing relative to the x-axis. Well, at that point, I'm going to look just really close around that point, -1, 0. So I'm going to put a circle around it, like that, and see what's happening at -1, 0. If you just look, and I am holding my hands up, not that you can see me, and blocking out everything except that little circle, it looks a whole lot like a line. To the left of x equals -1, my graph is above the axis. To the right, it's below. I'm going right through there. And it just looks like a line. Well, lines have degree 1, so the multiplicity there is 1. Now we're going to do the same for the other two x-intercepts. The next one is at 0, 0. And I know that just from looking at the graph. I need to know the multiplicity, so I'm going to look at what's going on there. Put a little circle around that point, like that. And again, if you can, look just at that little circle. Well, to the left of x equals 0, my graph is below the x-axis, and to the right it's above. So my graph is going through at that point. That tells me I have odd multiplicity. But it's not like the last one. It doesn't look like a line. It kind of jogs in the middle there. It curves. That looks more like a cubic graph. So the multiplicity, we can't just call it 1 because it doesn't look like a straight line. Well, the next best thing is multiplicity 3. It looks like a cubic graph. One more x-intercept, and that's at +2, 0. Need to think about multiplicity there also. So I put a little circle around just that point, like that, and look at only what's inside the circle. That looks like a little tiny parabola inside that circle. Well, parabola is y equals x squared. That's degree 2. Another way to think about it is I know there's even multiplicity there because my graph comes down from the left towards that point and then hits the x-axis and bounces back the way it came, which means we have even multiplicity. Well, now we know x-intercepts, we know multiplicities. Time to turn this into a polynomial. It's going to look like f of x equals something. I'm actually going to start with my x-intercept 0, 0. To turn an x-intercept into a factor, I'm going to have a factor of x minus the x coordinate. So x minus 0. I'm not writing x minus 0. X minus 0 is just x. Multiplicity is 3, which means I need x to the third power, x cubed. Now we'll go to the x-intercept -1, 0. I'm going to have x minus the x-coordinate of the x-intercept, which is -1. I'm not going to write x minus -1. I'm going to call that x plus 1. The multiplicity there we said was 1, so that's done. I just need one of those. There it is. And finally, I have x minus the x-coordinate of my last one, which is 2, x minus 2. And I need 2 of those, since the multiplicity is 2. Long story why I do it this way. It avoids fights with the computer. There we go. There's our polynomial that fits that graph.